Okay, we're back on the UALR final exam review for the college algebra class. We'll do problem number 14. We're given two graphs. We're asked to use the graph of f of x equals the absolute value of x to write an equation for the function represented by each graph. So these are transformations of the graph f of x equals the absolute value of x. First thing on this graph on number A is notice that the absolute value of x is a v that goes like this. So to get from this function f of x, this is our f of x function here. To get to this function, we need to reflect it across the x-axis. Sorry for the bad pen. And then we need to shift it 2 units left. To reflect the function across the x-axis, we multiply it by -1. So the reflection across the x-axis is going to take f of x and make it negative f of x. And to shift it 2 units left, we replace x with x plus 2. So what we want is negative f of x plus 2. So we take and we plug in, instead of absolute value of x, we have negative absolute value of, now take out the x and replace it with x plus 2. We can graph that and you'll see it will give us this graph. I'm going to go ahead and change the viewing window on my calculator to match this graph and let you see that this is the graph we'll get when we do that. So if I go from x equals -8 to, let's say 3, and y equals -8, looks like the same thing. And then let's graph what we just came up with. We came up with negative absolute value of x plus 2. Let's go ahead and delete this. So this is going to be negative absolute value of x plus 2. And if we graph that, we should see this graph right here. And we do. Now, I didn't ask you to graph it. I just wanted to show you that that's how we get. To reflect a function across the x-axis, we multiply it by -1. To shift it 2 units left, we take the x out and we replace that x with x plus 2. That shifts it 2 units to the left. And so our function, if we want to call this new function g of x, then g of x would be negative absolute value of x plus 2. That would be the equation for the function. And that would make this the graph of g of x. If we want to come down here and do the same thing, this time, recall, the graph of f of x equals absolute value of x is just this. This one doesn't have to be reflected. It just has to be shifted. It needs to be shifted 1 unit to the right and 5 units down. So remember, if we want to shift it 1 unit right, we replace f of x with f of x minus 1. And if we want to shift it 5 units down, we just subtract 5 from that and get f of x minus 1 minus 5. So if f of x is the absolute value of x, then f of x minus 1, we'll call this g of x. F of x minus 1 is the absolute value of x minus 1, and then I need to subtract 5 from that. And that will give us this graph. We can go ahead and calculate, put it in the calculator and graph it, and you'll see it's this. But that is the equation for this function here. They just called it y. I didn't realize that y was over there. So this would be absolute value of x minus 1 minus 5. And this one would have been negative absolute value of x plus 2. And that's how you do problem number 14.